Good evening or good morning, wherever you happen to be listening to this. And welcome to this evening's technical meeting, which is titled The Future of Design Standards, Has Simplification Become Unaffordable? So my name's Jane Entwistle and I'm going to be chairing the meeting this evening. So moving on, our speaker this evening is Steve Denton. You've been able to read about Steve. He's the Managing Director of the Civil, Intelligent, Infrastructure and Road units within WSP. Now, Steve was originally involved with the implementation of the Eurocodes in the UK, and he's now leading the development of the second generation of Eurocodes. But he's going to tell us all about that and much more about himself as he proceeds through his presentation. So before we actually invite Steve to take the floor, as it were, I just want to remind you about the copyright aspect of this. It's all there for to be read on the screen, but hopefully everything is in place so that there are no infringements. So with that, I hand over to Steve and we look forward to what you've got to tell us this evening, Steve.
Jane, thank you very much for your introduction. Let me share my slides and just check that you can see those okay.
Yes, that's fine. You can see the slides and we can hear you fine. Thanks.
Excellent. Thank you very much. Well, good evening, everyone, and good morning, good afternoon, depending on where you are around the world. Thank you ever so much for joining this session, and I hope you're going to have an interesting time as I talk through this topic around the future of design standards and pose that question: has simplification become unaffordable? So when I speak about standardization and standards, I often like to start with this quote. Like life in general, our codes seem to get more and more complicated. And when I talk to this quote in front of a room full of people, what I often see is a lot of nodding heads. You know, it's definitely the case that this statement resonates with people. But it also intrigues me, and it's particularly pertinent for this lecture because it's a quote that was taken from a discussion that took place in the headquarters of the Institution of Structural Engineers just a few days after I was born. This question around complexity or simplification within standards and codes is something that has been topical for many, many years. And it's what I'm going to dig into this evening. Now, it's certainly the case that the volume of our design standards has increased over the years. And this indicative graphic that my colleague Maria Pierangelino put together for her engineering doctorate on design standards just indicates some of the changes that we have seen over the years. And I do think it's always interesting and instructive to look back at history, and we can go back almost 4,000 years to the first design standard we know of in the Code of Hammurabi, where it states if a builder has designed and built a home and his work is not good, and if the house he has designed and built falls in and kills the householder, that builder shall be slain. It does always fascinate me when we look back over the years that for someone or for people who are involved in standardization work, it's kind of intriguing to see that even 4,000 years ago, they were writing performance-based requirements. And for those involved in contract negotiations, interesting that even in those days, they wrote contracts with pain gain mechanisms, albeit they focused on the pain side back in those days. But what I'm going to focus on today is more, and the examples I'm going to draw are more from the Eurocodes. And I'm going to talk specifically around some of the things that we've learned and observed through the transition and development of the second generation Eurocodes, work that I've been involved in for many, many years, and that I've been leading since 2013 as the chair of CEN TC250. And I always remember when I think around this and this topic around simplification of this decision, which I drafted at a meeting. I remember sitting in a meeting room in Helsinki overlooking the harbour back in 2010, and we were discussing as CEN TC250, the committee with overall responsibility for the Eurocodes, questions around simplification in standards. So whilst this topic, as I outlined from the start, has been meaningful in the broader debate around standards, it's also been specifically something that we have been mindful of in the development of the second generation Eurocodes, and we started thinking about what did it mean to us as far back as June 2010. Now, if I'm listening to someone speak and I'm listening to their viewpoint, I'm always interested in where their viewpoint is from, where are they coming from. So I thought I'd just give you a little bit of my background before we get into the main meat of the presentation. So as Jane said, my day job is as managing director for the Civil Intelligent Infrastructure and Roads units within WSP in the UK. But I actually spend a significant proportion of my time involved directly in projects, and have the opportunity to work on some really exciting and technically extremely complex projects. But I combine that role with the work that I do leading TC250 and the evolution of the structural Eurocodes, but also being Vice President of the Royal Academy of Engineering, held a visiting chair at the University of Bath for many years, and also worked as an advisor to clients and governments, both domestically and internationally. And so I've tried to bring all of those different perspectives to the work I've done in leading the development of standards. But central to that, my day job, what I do most of my time, is as a practitioner, and that is the primary perspective that I bring to the standardization work that I do. So in terms of this talk, I've split it into seven parts, but there's kind of three blocks. The first three blocks are really just exploring the concept around standards and simplification and where we've got to, and some observations on the work that I've been doing over recent decades. Then the second block is really looking forward. What are my recommendations for how we should be considering and how we should be developing design standards in the future? And then finally, some brief conclusions at the end. So I want to start off with why design standards matter. I think I have one of the best jobs there is in engineering. I feel immensely privileged having the role that I have, leading a fantastic business with brilliant colleagues, working on great projects for fantastic clients. And when you lead a business, you have a certain degree of agency in choosing which projects you focus your own time on. And I get to work on some amazing, amazing projects. So you might ask yourself, if I've got those opportunities to work on amazing projects, why do I spend time working on standards and standardization? And the simple answer to that is because I think it's really important. And I want to start off by outlining to you why I think that standardization in what we do in our field is so fundamentally important. And there are 5 reasons. The first is about impact. When the first generation of the Eurocodes were developed and implemented, the European Commission did an assessment of their impact. And they concluded that the first generation of Eurocodes would be used by around 500,000 engineers within Europe. And of course, they're used by many more engineers elsewhere around the world. And as you'll know, construction constitutes around 7 to 8% of GDP in most developed countries. It is a huge market. And so have to recognize that, the impact of design standards is really profound. How often do we professionally have the opportunity to do work that's going to impact the day-to-day lives of 500,000 professional engineers? That's going to impact directly on the design and then the construction of our built infrastructure and built environment that provides the hard wiring for our society and for our economies. It is a profoundly important and privileged role to be involved in design standards and development of design standards. One of the other characteristics of our sector is that the things that we design are typically at a scale which means it is impossible for us to undertake testing of our designs in advance of things being built. And when you contrast that with other branches of engineering, where typically it's possible to test products in labs and factories, it's really very different. And what that means is that we in the construction sector need a means by which we can verify the adequacy of our designs before they are built. It's a vital element of how the construction sector operates. and it is a functional role that design standards fulfill. One of the other characteristics of our sector is that it's highly fragmented. We have lots and lots of different parties who are involved in the whole life cycle of assets. And one of the consequences of having a fragmented sector is that it's really hard to learn lessons. And we know that standards provide a key mechanism through which lessons can be learned. And we know that that's true because when we look back in history, after there have been major events, or if there have been collapses or issues identified, it's often led to an intensive period of activity in developing standards and demonstrating the role of standards in providing that feedback loop. One of the other critical roles of standards is as a means through which we can embrace and drive a response to new societal demands, particularly important at the moment around sustainability and decarbonisation. And standards are a vital instrument in the way in which we can drive that change. And then finally, as a mechanism to transition research to application. Why do we do research? We do research because we want to enable innovation. We want to see change. And if we want that change to be of significance, then we want change at scale because that's what gives us real impact. What stronger pathway to impact do we have than seeing the findings of research transition into rules, provisions within design standards? And clearly they've got to reach a position of sufficient maturity before they are appropriate to be included within design standards. But once they make it into design standards, that is truly a mechanism to achieve real scale and therefore real impact. So you put those 5 reasons together, and that really answers that question of why do I spend time and why have I spent so much of my professional time and significant amount of personal time focused on standards and standardization over the last few decades. And one thing I would note is that actually I found it not only very professionally fulfilling, but I've learned a huge amount doing it. And I would say to all of you that there are opportunities to engage in standardization activities, and I'd encourage you to do so, very much encourage you to do so. Let me then move on to the second part of the presentation and talk about explanatory power and simplicity. So it's and in Bristol, where I'm sitting, it's a really nice evening. I'm sure for many of you, it's been a fairly long day. But in my book, it's never too late in the day to get into some fundamental structural mechanics, and that's what we're going to do right now. So over the years, I have run training sessions for thousands and thousands of engineers. And I've often used this image. And this is an image taken from the PhD research that I did at Cambridge quite some years ago. You can tell it's some years ago by the quality of the image, because back in those days, digital cameras were really pretty poor. But you'll be able to see that what this was a test on a reinforced concrete slab. And from the crack pattern, you'll understand that this was a slab that was tested. We're looking at the tension face of the slab. And it was tested actually with a point load, and that point load was quite close to the near edge of the slab at midspan. And the question that I'll ask people when I'm running those training sessions is, if you were designing a slab like this for that kind of load case, how would you analyze it? And generally what people will come back and say is that they would do some kind of linear elastic finite element analysis. Now, clearly this is a statically indeterminate structure. It's absolutely reasonable to look at some kind of distribution analysis, finite element analysis, for example, because determining the pattern of moments throughout this slab is not straightforward. And so finite element analysis, sure, I understand that. But then I'll probe a little bit around the linear elastic bit. Because what you can see from this crack pattern is that the final failure of this slab happened with a full width yield line mechanism all the way across the middle. You can kind of see that from the concentration of cracks at midspan. So since that's the way that this failed, how can we be confident that designing it on the basis of a linear elastically determined distribution of moments is safe. I mean, it's clearly a completely different distribution of moments from those that were in the slab at the point it fails. So I'll ask people, how do you sleep at night? How do you know that what you're doing is safe? And generally that will lead to a conversation and a bit of discussion and a bit of to and fro, and eventually um, someone will say, well, of course it's safe to do it because what I'm doing is I'm relying on the lower bound theorem of limit analysis, what you might call the why we can sleep at night theorem. The theorem that says if you can find any stress distribution throughout a structure that's everywhere in equilibrium with the applied loads, doesn't violate the yield conditions, it basically doesn't exceed the capacity anywhere, then those loads can safely be carried. It's an incredibly powerful theorem. I talked about that concept of explanatory power. It was in the sort of title of this section. And explanatory power is a kind of concept in the philosophy of science. And I think it's a lovely concept and particularly nice when you think about it or extend it to consider the ratio, if you like, or the relationship between what a theory enables you to do, what it explains, and what needs to be assumed for it to hold. And when you kind of think in those terms, I think this lower bound theorem of limit analysis has a really high explanatory power. Now, for scientists, the concepts of explanation can get really involved. But for us engineers, where our desire is really about utility, I think the notion of explanatory power really resonates. I mean, what does it mean? It means that if we can come up with a simple theory that's really useful, that's simple to apply, simplifies what we do, then it's immensely powerful. And that's absolutely true for the lower bound theorem of limit analysis. We use it all of the time. And it has some really powerful corollaries as well. One of those corollaries is that if we have any self-equilibrating stress system within our structure, then that won't affect the ultimate limit state capacity of that structure, resistance of that structure. And we kind of know that's true because it's not, a self-equilibrating stress system is not going to invalidate the equilibrium with the external loads. So that's a really powerful corollary, and we'll come back to that a little later. But all theorems have or rely upon underlying assumptions. So if you're using this theorem, if we're relying upon it day to day, do we know what those underlying assumptions are? Well, there are four. And at least two of them are really important to know. The first is that displacements are small, and that means that that they can be reasonably neglected in the equilibrium equations. So the first is small displacements, and the second is that materials are ductile or that they have sufficient deformation capacity, which essentially means the size and position of the yield surface is fixed. And then the two that can often apply, but probably we don't need to worry about so much, is around the yield surface being convex and a thing called the normality condition applying. But those first two should absolutely be in our consciousness, that displacements are small and materials are ductile. So if I'm talking about standards and simplification, why have I taken this detour into this basic fundamental structural theory? Let me demonstrate why. And I've drawn in this talk, and I will again, a number of examples from the second generation draft of EN 1992. That's the standard for the design of concrete structures. And I've just extracted a clause from it here. And this clause says the effects of restrained imposed deformations may be neglected at ultimate limit state. That's really convenient. Yeah, that's really convenient. Now, what do we know about restrained imposed deformations? It's that they generate self-equilibrating stress systems. So we can neglect them at ultimate limit state according to the lower bound theorem of limit analysis. But you'll see if you read on this clause, where it can be demonstrated or has been shown by experience with similar structures that. So what are those conditions? Those conditions are firstly, that there's sufficient deformation capacity or ductility. And the second is that the structure is not sensitive to second order effects caused by large displacements, i.e. that we're looking at a small displacement situation. So you'll see here that those conditions around being able to neglect the effects of restrained imposed deformations link directly to the assumptions that underpin the lower bound theorem of plasticity or limit analysis. And if those assumptions don't apply, then we have to go elsewhere for much more detailed analysis. I always remember a conversation that I had many years ago with an engineer who really inspired me, one of my kind of engineering heroes, I suppose. Professor Peter Marty, who was then the professor of concrete structures at ETH in Zurich. And I remember talking to him back in the early 2000s, I guess that conversation must have happened, when at the time I was doing work on some of the early work on use of fiber polymer composites in structural applications and conjunction with concrete. And there was a lot of research going on at the time in that field. And inevitably, one of the concerns was that you don't necessarily have that much deformation capacity when you're using brittle materials, and their behavior in conjunction with concrete, particularly if they're bonded to concrete, can be quite brittle. And so I said to Peter, are you going to do any research in that area? Are you interested in that field? And Peter's response to me was, well, not really, because what he was really interested in was how we design structures so that they do satisfy those assumptions that underpin the lower bound theorem of plasticity. And what that brought home to me was that actually, in many ways, this is a choice. That what we've got in this clause is a really nice simplification. We can apply it so long as we satisfy those requirements around deformation capacity and small displacements. But if we don't do that, then we're going to have to do something more detailed. So you see there's a choice here. It could be that you could write this clause to say you have to have sufficient deformation capacity in your structure and explain what that would mean, and that you have to have small displacements. And if that were true, you could always neglect these effects at ultimate limit state. But actually, as engineers, we'll often make a choice that that isn't a constraint that we're happy to have. And we might well make that choice in design, but actually one of the other changes that's been much more prevalent since that conversation I had with Peter all those years ago, and it's embraced within the second generation Eurocodes, is that we spend an awful lot more time, and it's really important work, focusing on the assessment of existing structures as well as the design of new structures. And in fact, the scope of the Eurocodes is being extended in the second generation to cover aspects of the assessment of existing structures as well as the design of new structures. And the significance of that here is that when you're assessing existing structures, you don't have those choices. You basically have to perform the analysis which is appropriate to the structure that you're assessing. And that means dealing with the materials that you've got, the geometries that there are, the detailing that's been done. And so you haven't got that flexibility. You haven't necessarily got that choice. And what we need within our standards are provisions that equip us with the tools that we need in order to be able to undertake our analysis and to verify the adequacy of the structures that we encounter. Let me move on to part 3, talk about meeting users' needs and the evolution of EN 1992. So perhaps just starting with a little bit of an overview around the evolution of the Eurocodes. So the new structure of the second generation Eurocodes is indicated on the left-hand side. And these standards are being developed, as I said before, under the responsibility of CEN TC250, which is a committee where we have a series of subcommittees that take responsibilities for each of the Eurocode parts, and then a number of horizontal groups and working groups and other groups to oversee the combined effort and try and ensure alignment between the activities at the subcommittee level. And an important thing to acknowledge is that the development of the Eurocodes is that the Eurocodes are design standards, but they operate as a system in combination with other European product and execution standards. And that's really fundamental to the way in which the Eurocodes are developed and their role within this wider system and family of standards. Now, in the evolution of the Eurocodes, a really important stimulus for this, it opened really important opportunities for us, particularly in relation to funding and support from the European Commission, uh, was a thing called Mandate 515. These days, it would be referred to as a standardization request. And this is when the Commission wrote to CEN, setting out some aspirations, desire for how they would like to see the second generation of the Eurocodes developed. And as TC250, we brought together, in the end, it was around 1,000 experts that contributed to developing our response to that mandate document, setting out how we intended to respond to those changes and aspirations that were set out within Mandate M515. And the fundamentals that we set out in that document ended up being key to the way in which we've approached the evolution of the Eurocodes, 4 overlapping phases, a whole series of different tasks delivered by international project teams formed through international competition. We set out a very detailed plan for what we intended the work we intended to undertake. But one of the other things that's probably worth sharing around the evolution of the Eurocode is whilst that Mandate M515 work program provided, if you like, a sort of top-down strategic direction for us, what we also did in the early stages of the Eurocode's evolution was to undertake or invite systematic review feedback from the 34 European countries that are members of CEN on a clause-by-clause basis, but also on a more holistic basis for every single one of the Eurocodes, the 59 Eurocode parts in the first generation Eurocodes. And we received thousands and thousands of comments, and all of those were catalogued, they were responded to, and those that we chose to act upon were then built into the evolution program for the Eurocodes. And again, just to give you a little bit of a flavor of some headlines around the evolution program and just its scale, is that when I last counted them, which was a few months ago, there were 129 active subcommittees, working groups, and task groups within the TC250 family. I mentioned earlier that the Eurocodes operate in conjunction with other product and execution standards. Those are under the responsibility of other technical committees. So we have 46 active liaisons with other technical committees. We formed 76 funded international project teams through international competition across the 4 phases of our work program. We've obviously followed all of the CEN rules around opportunities for comment through inquiry and formal vote, but we also wanted to make this a much more inclusive effort, and we've had more than 300 formal opportunities where we've reached out to the CEN members and sought comment on preliminary and more detailed drafts of the standards. And despite the fact that we delivered significant amounts of the work during the period of COVID, we actually managed to deliver all of the European Commission funded M515 work to budget and program, and all of those deliverables were accepted by the Commission with no queries. And we sit today on the cusp of hitting our target for the conclusion of the formal vote process and the release of all of the second generation standards to the 34 CEN members by early 2026, and we remain on track to achieve that deadline. And we've done that with thousands of experts engaged across Europe in this work. I think there are probably somewhere between 1,000 and 2,000 experts who are actively engaged in the work at a European level. And when you recognize that most countries, many countries, will have mirror committees shadowing that effort, it means that we're probably in the range of about 15,000 experts that have been engaged in the Eurocode evolution activity over the last decade or so. So it is a huge program. In fact, the largest program by funding level from the European Commission ever in European standardization history. But what does it actually end up looking like? Why is this relevant to the point around simplification and complexity in standards? So this is the new structure. I said I'd use EN 1991 as a reference, and here I've set out for you the new structure of EN 1992. Here I've set out the new structure of EN 1992.11, and for those of you familiar with the Eurocodes, you'll see that the numbering is slightly different, but we've basically retained that same structure of having a consistent model across the Eurocode parts, where the clause or the section headings mirror across the different standards. And 1992 also has 19 annexes. And when you add up the number of pages, it turns out that this new EN 1992 has about 400 pages. And some of you listening to this will be thinking, kind of, what have you done? Why do we need a standard with 400 pages? How can that be helpful? Is that really necessary? I mean, let's dig into that a little bit more. If we look at the annexes, for example, here are the 19 annexes. And when you read down through them, you could ask yourself the question, is all of this necessary? Do we really need the content on steel fiber reinforced concrete structures? Is it really necessary to have that in here? Could we have made it a shorter document by omitting that content? You know, my response to people thinking along those lines is, well, if you don't need it, you don't need to look at Annex L. But actually, if it is relevant to you, what would you do if it wasn't there? What you'd have to do if it wasn't there is you'd have to look in some other document, and then you would have a host of questions about, is that content in another document fully compatible with the rest of the Eurocode suite? How does this all fit together? Would it really be simpler if that content was elsewhere? Let's continue digging in a little further, because as you know, the title of this talk is around, has simplification become unaffordable? And when we talk about affordability these days, we need to think not just in financial cost terms, but in carbon cost. And when you look at the annexes and the content, the normative content within EN 1992, there's a host of material which is really important from a cost, but also even more important from a carbon perspective. You know, what can we do as structural engineers to drive down the carbon intensity of what we do? Well, one thing we can do is to make the most efficient use of materials. So unlocking opportunities to do more complex and sophisticated analysis where it's appropriate to do so through nonlinear methods or adjustment of partial factors within certain constraints, or just simple specific rules. We know that when you confine concrete, it increases its strength and it improves its deformation capacity. We don't normally take advantage of that effect. But now we have clauses within the Eurocode for concrete structures that allow us to do that, and therefore improve the efficiency of our use of materials. You know, we've introduced content on recycled materials into the scope of EN 1992. We've got new coverage around durability. And you know, as structural engineers, I think one of the biggest contributions that we can make from a decarbonization point of view is actually to extend the life of our existing assets. Many countries around the world, a huge proportion of our buildings and infrastructure that we will have in future years exists today. And if we can extend its life, if we can justify extending its life or adapt structures to extend their life, that's clearly one of the great contributions we can make from a decarbonization perspective, or reducing, at least avoiding the carbon costs of demolition and replacement. Again, those topics around assessment, strengthening of existing structures are included within the new Eurocode suite. Now you could look at this and say, well, does it make it simpler? The honest answer is no, I don't think it does make it simpler to have this content within the Eurocode. But hence the title of the talk, has simplification become unaffordable? Because actually when we go back to the standards, simpler standards of the past, they simply wouldn't have put the tools in the toolbox to be able to do some of these things today. Let me continue digging in a little deeper. If you start counting clauses, so I went through and counted the normative clauses covering different topics within EN 1992. We've got significant coverage around pre-stress, around fatigue, around second-order analysis, around membrane and shell elements, strut and tie, and nonlinear analysis. And you could pose that question: do we need all of this material? Well, again, let's look at a clause. So, in EN 1992, on the section on methods of analysis, this clause around linear elastic analysis, a really convenient and helpful clause, except where specified otherwise. We'll come on to that in a minute. Linear elastic analysis may be carried out for the determination of action effects, assuming uncracked section properties, linear stress-strain relationships, and a mean value of the modulus of elasticity. That's an incredibly convenient clause. It's particularly convenient that the code says that it's fine to use uncracked cross sections, because at the time you're doing your initial analysis of action effects, of load effects, you don't know what reinforcement you've got in your structure. So the fact that you can work based on uncracked cross sections is incredibly useful. It's incredibly convenient. This is a really lovely simplification. Does it always apply? Well, it doesn't apply if we've got second order effects, large displacements coming into place. Where second order effects are relevant, then we've got to take account of cracking, of nonlinear material properties, of creep. We've got to descend into those 23 clauses of pain that I showed on the chart, on the page, on the slide before. So I want to return to this quote. Like life in general, our codes seem to get more and more complicated. I imagine when you read that, and if you agreed with it, and those nodding heads that I often see in rooms full of people when I talk about this subject, then you would have seen that word complicated pejoratively, as a negative. And I think we should challenge ourselves on that point. We're professional engineers. We are responsible for the design and analysis and management of much of our built environment, of our infrastructure. We are equipped to be able to undertake really complex tasks, and we need to sometimes. It's part of what we are capable of doing professionally. I feel like we should wear our ability to undertake complex analysis where it's merited as a mark of honor, not some kind of badge of shame. Why should we feel like we need to simplify or avoid doing complex things where it's appropriate to do it? And where it's relevant, and where it's appropriate, don't we need our standards to include the coverage of those things which are just inherently complex, because what we're dealing with is complicated? Is that a failure of our standards? I don't think it is. I think it's something as professionals that we want to have available. It doesn't mean we always need to use it on every project, but it should be there. It should be at our disposal. So with that, let me move on and think about the future. The first topic I want to cover is about ease of use. So when I sat in that meeting room overlooking the harbour in Helsinki, I remember it vividly, writing this decision, this resolution that was unanimously agreed. Although we were talking initially about simplification, a really important point that this resolution made was it shifted the vocabulary from simplification to ease of use. I think that's really important. I think it's really important that we accept that some of the things that we do as structural engineers will be complicated. But that's not a reason why our standards need to be more difficult to use than they need to be. They don't need to be more complex or cumbersome than they need to be. That we can embrace the fact that some of the things we do are inherently complex and still have a real driving desire to achieve ease of use in our standards. And when we embarked on the evolution of the Eurocodes, as TC250, we set ourselves two key overarching aims that have guided all of the work that we've done on the development of the second generation Eurocodes. And the first of these was to enhance ease of use, and the second was to try and achieve exemplary levels of international consensus. Now, we not just set that ambition to enhance ease of use, but we thought really deeply about what did that mean and how could we go about it. And one of the first things I did when I became chair of TC250 was I established an international panel, 16 people, to really unpack and understand what we meant by ease of use, what that objective really means. And that team developed a paper that was unanimously endorsed by the 34 CEN members. It included this statement of vision about the second generation of the Eurocodes being a more user-orientated suite of design standards that are recognized and most trusted and preferred in the world. That set a vision, but we also thought hard about the mechanics of how we go about it. How do we make this happen? And we recognized 5 pillars that we felt were fundamental to doing this. Statements of intent to meet users' need, principles and related priorities, examples, some performance measures, and then putting in place the right arrangement for management, governance, and support. And I'll come back and talk about these things over the next few slides. Now, when you have got thousands of people all working together to draft a common suite of standards, it's absolutely critical that everyone has an understanding of who your primary target audience is. I think it's true whenever you write anything to think, well, who am I writing this for? So one of the first ease of use decisions that we took was to say, who are we writing the Eurocodes for? And we settled on this, that our primary target audience were practitioners, competent engineers, that's the way we defined it, as competent civil, structural, and geotechnical engineers, typically qualified professionals able to work independently in relevant fields. But we absolutely recognize that whilst that was our primary audience, actually the Eurocodes were used by many, many other groups. And so we set out from the start a series of statements of intent for each of those categories of Eurocodes users. So for our primary target audience, our statement of intent was to aim to produce standards that are suitable and clear for all common design cases without demanding disproportionate levels of effort to apply them. Or for expert specialists, we'll aim not to restrict innovation by providing freedom to experts to apply their specialist knowledge and expertise, and I'll come back to that later. Or for educators, aiming to use consistent underlying technical principles irrespective of the intended use of a structure. Or for regulators, to produce standards that can be referenced or quoted in national regulations. And it was interesting when we first put these together because there were some people who were nervous that writing these down, making them very public, was creating a rod for our own back. But my view, and the view that held, was that actually it was really important to be transparent about what we were looking to achieve. And ultimately, those people using the second generation Eurocodes will be able to judge how well we've achieved these statements of intent. But certainly they provided a guide to us, a means by which we could assess decisions, a reference point for the decisions we made. And as I said, there are actually some very practical things you can do when you're drafting standards that are relevant here. I talked earlier about the expert specialist category and the statements of intent associated with this. We will aim not to restrict innovation by providing freedom to experts to apply their specialist knowledge and expertise. Now, one of the real tools you've got when you're writing standards is the verb form that you use within clauses. One of the changes that we've made between the first generation and the second generation Eurocodes is that we have included explicitly the drafting intent behind those verb forms in the Eurocodes themselves to eliminate the ambiguity that I think sometimes crops up when people don't necessarily have a knowledge of the intended meaning of the different verbs that are used within standards. And we also wanted to be absolutely clear what we meant when we used these words. So you'll see that a shall is a requirement that strictly has to be followed. A should is a highly recommended choice, a strong recommendation. A may is a permission. Anyone can deviate from a may. A should, you need to make sure that you're still satisfying any national regulation and contract provisions, but provided an alternative is technically justified, then you can deviate from a should, a recommendation. And you can see that when you're drafting, if you make sure that you're not elevating your provisions too far towards the shall end, but getting the right balance between the shall, should, and may provisions, then what you do is you work towards satisfying this statement of intent, providing that freedom for experts to apply their specialist knowledge and expertise. And you'll see on the right-hand side of the slide the breakdown of verb forms in the normative content of 1992, and you'll see that balanced position between the shall requirements, the should recommendations, and the may permissions. On principles and priorities, that second pillar, you can see we split these into general principles and specific principles. So starting off about clarity and understandability, the second around ease of navigation. And then in terms of the guidance, management, support, measurement, all of these things, there are a number of innovations that we brought into the Eurocode Evolution program that were novel in the international standardization world. Through international competition and funding from the Commission, we appointed a technical reviewer to look at making sure that we were following the ease of use principles that we had set out and translated these into specific guidance and recommendations to all of those involved in drafting, and then also reviewing all of the drafts that were produced to check for their alignment with the rules and the principles that we had set out. You see, one of the challenges when you're working on a standardization effort of this kind of scale is that at any point in time, the focus of individuals in a team will typically be on a subsection, a series of clauses, a particular block of text within a particular standard. But as users of standards, what you use as standards is actually a suite of standards. You will be using multiple documents. What matters to you is that there's consistency across the suite so that similar expressions are used. Things are framed and phrased in similar ways, so that you're not there kind of questioning yourself about why there might be a slightly different phraseology between one standard and another. And that's the kind of thing that we have sought to drive through with the guidance and the management, support, and measurement that we've put in place. And in terms of where that's taken us to on the Eurocodes evolution, let me give you a few metrics here. So one of the things that we're doing is we are looking at page count, variation in page count between first generation and second generation Eurocodes. And we're also looking at NDPs, the nationally determined parameters, because one of our aspirations has been to reduce the number of NDPs. Now, clearly in the second generation Eurocodes, we're covering significant areas of new scope from the first generation. So automatically that introduces additional content and additional NDPs. But for the first 24 second generation Eurocodes that we've done the analysis on, we've looked at the like for like. What was covered in the first generation Eurocodes? How is it covered in the second generation Eurocodes? And what we've achieved is a 13% reduction in page count and a 30% reduction in the number of NDPs. In fact, over nearly 32% reduction in the number of NDPs. And in terms of that question around exemplary levels of international consensus, where have we got to? And are people comfortable that we've been fulfilling our objectives and meeting our objectives? And so far, we have taken around 50 standards and technical specifications through the formal vote procedure. 34 countries, each having the option to vote on those. So thousands of votes could have been cast. And out of all of those, the proportion of negative votes cast is fewer than 0.4%. So I think that gives me some comfort that at least in terms of the ambitions that we set ourselves as TC250, we are going a considerable way to fulfilling them. Ultimately, you'll be the judge of whether we've achieved some of these ease of use ambitions. But the thing that I guess the point that I really want to make, the point that I'm really trying to emphasize, is I think we need to be careful around the vocabulary that we use. That conversation around complexity and simplification, I think that's unhelpful. But I think it's really important that we have a conversation about ease of use, and that whenever we're developing standards or regulations, we need to be thinking about how can we achieve the highest possible levels of ease of use. And I think some of the approaches, principles that we've embraced and invented in the development of second generation Eurocodes are a really helpful framework that others might be able to adopt in the future. The next future-facing concept I want to talk about is levels of approximation. So it's always kind of been the case in standards that sometimes you're offered a simplified method and a more complicated method, a more general method. What Aurelio Matuni has done with co-workers is to really formalize this approach into what he refers to as the level of approximation approach, and this is embraced within the FIB model code, and there are a number of papers that Aurelio has produced. And I really like this. It's not, we've embraced some of these concepts within the second generation Eurocodes implicitly, but not explicitly in the manner in which it's been done within the FIB model code. And the concept here is really to recognize that we can undertake analysis with varying levels of accuracy. But as we get to, or if we use those more sophisticated methods of analysis, those higher levels of approximation, it takes more time. But what's the payoff? Again, what Aurelio talks to is the payoff actually in terms of cost. If, for example, we were looking at designing strengthening works for a structure, and if we use the more simplistic levels of approximation, then whilst the engineering fees might be low, you'd end up having a much higher amount of strengthening works, and therefore the overall costs go up. And actually, as you move to the more accurate levels of approximation, those minimize or hopefully eliminate the need for strengthening works. So whilst the engineering fees may go up somewhat, the overall costs are a minimum. And there's something I like around this formulation. Firstly, I like the transparency. You know, in terms of the conversations that we have with designers and checkers or with clients, I kind of like the transparency of this concept so that it can be agreed at the outset, if we're commissioned to undertake a piece of work, at what level we're going to be operating. And what's also really nice in some of the examples that Aurelio and his co-workers have developed is where we actually have mechanical consistency between the different levels of approximation, and really what changes is refinement upon the mechanical parameters that feed in. I think there are concepts here that can be developed further as well. It's not so explicit in some of the work that Aurelio presents, although when I've spoken to him about it, he assures me it's in there. Is actually at some of the lower levels of approximation, actually those are only valid with certain bounded restrictions on scope of application. And so actually sometimes you have to progress into the higher levels of approximation because of the constraints, the boundary conditions, if you like, to the applicability of some simplified methods. And I think there's room there for some of these concepts to be teased out a little further. But I like this model, and I think that it is something which, as we work to the future of developing design standards, we should think about further. And then my third thought around the future of design standards is actually about how we use them. Now, I really like libraries. You know, one of the things that I took away, one of the strongest things I took away from doing a PhD was a sense that whatever topic I'm looking at, whatever I'm working on, there's every likelihood that someone significantly smarter than me will have spent significantly more time than I'll ever probably be able to thinking about the issue that I'm exploring. And they will have written that down, And my starting point should always be to build upon what work people have done in the past. And I love having that. I think whenever you're in libraries or bookshelves I have behind me, it just reminds me of the importance of making sure that we capitalize on the huge repository of knowledge that is available to us. But we also need to recognize that that image on the left does not represent the future consumption of design standards. The future consumption of design standards will be digital. Yet actually the way in which we currently think about standards is really akin to, what are PDFs? They're a kind of digital paper, aren't they? But we're not thinking about the way in which we consume standards in a truly digital sense. And that needs to transform. And I know just what's possible because we had the opportunity and the privilege to work with National Highways over many years, supporting them with the development, the digital transformation of the DMRB initially, and now the MCHW. And National Highways had a really bold vision. I think they've done internationally leading work in this area to completely digitally transform the way in which their standards are developed and the way in which they are accessed. And this has included tools, a whole platform within which the standards are drafted, which automatically includes within it the drafting rules so that issues are picked up in real time when you're drafting, which generates huge efficiencies actually. But also all of the comments and all of the background notes during drafting are also housed within this same platform. And I think that is immensely powerful and helpful and really an exemplar of how things can and should be done in the future. And the benefits of this for National Highways were really considerable. I mean, here are just a few of the metrics, but you'll see, a 70% reduction in the cost of drafting documents through online collaborative working compared with past practices, an 80% reduction in the time taken to draft new documents. The savings of the program of work within National Highways were measured in the millions just in terms of the cost of doing the updating, but actually the beneficial impact of drafting the new standards, again, you'll see that 30 million figure at the bottom. Just a transformation in culture, tools, processes, fueled by this digital innovation has delivered huge benefits. And I think when we're looking to the future of standards, the future of standardization, we need to recognize that the future is about how we consume standards digitally. And I think my vision here is that when we think around standards, we should be thinking about them being an entry point that if you want to get information on the interpretation of a standard, you really want to have that clause on the screen. You want to be able to click on it and use it as an access way into a knowledge compendium that explains the background to this content. We want to have digital versions where the national annexes are embedded within the standards, for example, so we haven't got to deal with duplicate documents. We want to be able to mesh the standard content with our workflows that we use within design, all of these things. And I think all of these things are become increasingly possible. And actually, again, with the Eurocodes evolution, one of the really important changes that people won't see initially, but it's been quite a significant effort in order to achieve it, is that the second generation of Eurocodes will be released to the national standards bodies like BSI in the UK, not just as Word and PDF documents, which is the way in which you generally buy standards, but also in XML version. And the fact that all of the information, the data within the standards is available within XML versions, then unlocks so much potential to be able to build that kind of knowledge ecosystem that the standards can be a part of and maybe a central part of in the future. So that then just takes me through to conclusions. So I hope what I've at least prompted you to think about a little bit in this talk is my view that simplified standards inhibit engineers, that they can have unaffordable sustainability impacts because they could lead to, for example, inefficient use of materials when designing new structures or unnecessary strengthening when assessing existing structures. As I said before, I think we should embrace our ability as structural engineers to tackle the complexity within the projects that we're dealing with as a badge of honor, not some mark of shame. No, we should recognize that sometimes our standards need to give us general and complex methods to deal with complex situations. Although there's a but, and that but is that this does not mean that we need to develop or accept unnecessarily complex or cumbersome standards. So what should we be doing to prevent our standards being unnecessarily complex or cumbersome? Well, I gave you my 3 thoughts. The first, focus on ease of use, not dumbing down. Maybe learn from and embrace some of the things that we did in the second generation Eurocodes development, some of the things I shared with you today. Second, maybe think about whether we should be formalizing a little bit more concepts around levels of approximation, providing that transparency and flexibility of different levels, more simplified and more complex methods that can be available. And in the second generation Eurocodes, absolutely we have those. And one of the changes we've made from an ease of use perspective is that you'll often see in the first generation, we'll put the general method first and a simplified method second. So as a designer, you kind of have to wade through the complex one to get to the simple one. We've inverted that in the second generation Eurocodes so that the simplified method within constrained bounds is presented first and the general methods typically are presented afterwards. And then finally, that recognition that the future development and consumption of standards will be digital. And that what we need to do when we think around the future of standardization is how can we unlock this transformation in their use and integrate standards into workflows and a wider knowledge ecosystem.